The name of this video is Debugging Light. In lesson 2 of the course, I'm going to go deeper into debugging with a more involved lesson, but I thought it would be important at this point, before you start to get into some of the in-video exercises and the assignments, to go over some debugging and cover what are the 3 most common errors that early programmers will face and make. So the first question is, what's debugging? Well, debugging's when you have a problem in your code and you're trying to figure out why it's not working. So you're trying to hunt down that bug and resolve it. So for example, if I run this code, down at the bottom of the screen in my editor, I get an output that the interface, that section of the interface, turns pinkish color, and I'm given a message and something called a traceback. And so these items that you see in the output when you get this pink screen are little clues that will help you track down what's wrong with your code and why it's not working. So this is one that we've seen before from the last lesson, and it's the message is saying the name int x is not defined. And then the traceback is telling me where I might start looking for that error. So it's telling me line 6. So I look up at line 6, and I notice that I've written int x differently than I wrote it when I assigned the variable. So that's what my problem is, and this is a very typical problem for early programmers, is to not write the variable the same way when you use it after assigning it within the code. And so Python is telling me that it doesn't know what int lowercase x means because I haven't defined it, I haven't assigned it in the code. So this one's fairly easy to correct. I just find where I've written it incorrectly and I correct that, and that should work. So now it's running 5 and it's printing out the integer 5. Next, another common error is to forget a parentheses. So if I turn this line on, line 9, and we run this, and I can turn off this, so it's Shift Control C to comment out multiple lines. So I'm going to run this, and I'm getting a rather strange error that says something about a syntax unexpected EOF while parsing. I'm not exactly sure what that means. And it's throwing an error in line 16. Well, line 16 isn't even turned on. So maybe let's turn on a line below this line to see if we can figure out what's going on. So I'm assigning point here these values, and it should run that. Let's run this again. Okay, now I'm getting an error, syntax error, a different one called unexpected token point. And so this is rather strange because it's throwing the error in the line 10, the one I just turned on, and this looks totally fine. I have, a variable, I'm assigning it these values, everything seems to be fine. So I look in the line above it and I have add line. Well, I could check to see if this is actually working. Run it one more time. Get the error again, and it's not producing a line. So something's going wrong with this line. So what the problem is that every time when I have a function, the assignments need to be contained within their own parentheses. And so what I'm missing here is the end parentheses of my function, which closes it or stops it. So why this is throwing the error in the line below it is that it's seeing the line below it as part of that function. So it's seeing this line as continuous because I haven't ended this function right here. So I need to end that by putting a parentheses on the end. The editor also does something that's pretty handy, is that it shows me pairs of parentheses. I always have parentheses in pairs. So when I'm writing a point like this, it's showing me the closed, it's showing me the partner of that parentheses. So this is showing me the partner of that parentheses, this one, that one. And so the ending one here, if that was missing, it's going to not show me an ending or a partner of that parentheses. So I need to have that in place, which ends the line of the function. And now that should run. And it does, it creates that line. So that's another one. If you're getting a sort of strange error, and it's sort of showing up in a line that doesn't seem to have an error in it, that seems to be written correctly, it might be that you've forgotten a parentheses in a line or two above it. Third one is giving a function incorrect data. So I'm trying to add another line, and I've written in the variable line, which I've created here. So whatever I've produced out of this function, I'm holding within that variable line, and then I'm feeding it into this function line here. And it's telling me an error, could not convert this long set of characters, which I recognize as a GUID, to a point 3D. But I see something strange in the traceback. So the traceback is telling me to look at 3 different lines, and 2 of those lines I don't have in my code. So 655 and 480. So I don't have that many lines in my code. But if I look a little bit further, it's showing me that that's really part of the sort of structure of the editor. So it's showing me iron Python and some other path settings. So what that's really telling me is it's throwing an error sort of in the works behind all of this stuff, behind the code. There's a code behind this code that's getting it to run, and it's throwing an error in there. Well, I can't do anything about that. I can't look in that code. But then I recognize there's a line 13 here. So that's the one I want to look for. So you sort of want to ignore the ones that seem outrageous in terms of their line numbers and look for the ones that are more obvious that they would be in your code. So it's throwing an error at line 13, and it's saying it could not convert this ID to a 3D point. Well, a couple things to ask here is what is line carrying and what is add line looking for? So the first thing to do is look at, well, what's add line? What do I actually need to give it? So if I go under my help menu and I look up that function, add line, I can look under parameters. This is what it's asking for. Okay, it needs a start and an end. It needs points. Now it also, so it says a point, which I understand is coordinates, but it also has a GUID. I'm giving it a GUID, but it's not recognizing that GUID as a point. So I need to give it points. Now there's a difference here between these two things, but they share something if they're a point, and we're going to talk about that in the next part of this lesson, is what really constitutes a point in Rhino space and also in Python space. But I would assume now that I need to give it point data, and I'm not giving it the right thing. Either I'm not giving it the correct GUID or I'm not giving it the correct point data. So one thing to ask is, what is line holding? And the easiest way to find out what something is holding, what a variable is holding, is to print it out. So if I type in line here, and what I'm going to do is temporarily turn off line 13 by putting a hashtag in front of it. I'll comment it out so it doesn't run. And then I'm just going to print out, what I want to do is just print out what's being held in line. So I'll run that, and it shows me that there's an ID being held in line. And because it's output from the function add line, I understand it as a line. So that's not going to work because this needs a point. It's not going to work with a line. So I understand that point here is holding a point value, so I can put that variable in here. And we'll run it again. And I'm going to turn this off to make sure that that creates that line. And now it's telling me line is not defined because I've turned that off. So I've turned off that line of code, line 9, by putting a hashtag here. So we need to either turn this off or print something else out. Well, I'll just print out point. And that's what it does. So in debugging, especially when you're first starting out and we haven't really looked at other ways of seeing what variables are holding, the print function is going to be your best friend because it's the way that you really find out what's being held in a variable. You just print it out. And so there's a mantra you should remember, a mantra for this course. When in doubt, print it out. So when you're doubting what you know is being held within a variable, just print it out to see what type of data it is. You could also use the type function to see if it's the correct type. But chant this to yourself over and over again. When in doubt, print it out. And that's one of the basic fundamentals of debugging. So the title of this video is What's the Point Lesson? And so if variables are the fundamental building block of code, then points are the fundamental building block of geometry in Rhinoscript. It's critical to understand a little bit about them because there can be some tricky issues with inputting them and creating geometry and outputting geometry from Rhinoscript using points. And we use points for all different kinds of things, from creating just lines to using them as the center of circles to the edges of rectangles, and even creating more complex curves, NURB curves, which are using control point structures. And we're also going to use them when we input curves. We're going to extract points from those curves. So we're going to be able to find endpoints and midpoints. We can bring curves in and divide them. So we'll find a series of points from them. If we had more irregular shapes, we can derive not only centroids, but also control points from them. And this is going to hold true, too, for when we start working with surfaces. We use points to create surfaces from. And we're also going to input surfaces that we're going to evaluate points along. And we'll get into that when we get into the lesson on surfaces. So in all of these share the fact that points are fundamental to their geometry, not only in terms of their creation, but also in terms of their extraction. So what is a point? Well, a point in Rhino space is a coordinate value, x, y, z. And that's determined by its location in the world coordinate system. It's an actual value, so let's say in this case, for example, this is a 220 point. Because it corresponds to two values and two values along the x and the y, and it's flat on the z plane. So the point carries with it those values, but it also carries with it another piece of information. It carries its globally unique identifier, or GUID. And so when we input a point, let's say this is our Rhino space. I have a line here, and this is our Python space. This is our editor. When we input a point using something like, get object, what we're inputting is this GUID. So that's what comes into Python space, is the reference to that point. Once we have that point in Python space, we can use it then to create geometry. So if we use a function like add line, it will accept a GUID. Now, some tools, some functions, and some things that we do within Python space will not accept a GUID as a piece of data, because they can't extract from that piece of data the coordinate values of that point. And so we'll have to use another tool like point coordinates to extract that value. If we get an error that says, you're giving me a GUID, but what I really want is a 3D point, then you'll have to do that. And so this characteristic of a point being both a GUID and a coordinate can lead to some errors and some confusion within the code. More often than not, what we're using when we use add line is we're going to use coordinates. So when we're working within code, a point is a series of values. Okay, if it's not something that I'm inputting from Rhino space as a GUID, more often than not, it's just this series of values. I can use those series of values to create that line in space. Now, what's maybe confusing sometimes about the characteristic of that line is those points that I'm using here as values within the code don't show up as points within Rhino space. And if I wanted something to show up as a point within Rhino space, I need to use a function called add point. So if I write add point and then give it a coordinate value, it's going to, in a sense, render a point out in Rhino space. Okay. And it's also going to return, and if I was to print this out, what that's returning, that would be returning a GUID of that point that's rendered out in space. And so this can often lead to confusion because people think that they need to render a point out in order to use it as a point within the code. And you really don't need to do that. And so let me just erase this. And if we bring our line back, so that's Rhino space, that's our Python space. So if you remember, to remember anything from this lesson is the fact that a point rendered out in Rhino space carries two things with it. Carries a GUID and carries a series of coordinates. And when I bring it into Python, it's bringing that GUID. Sometimes I'm going to have to use something to extract from that GUID those coordinates. The other thing to remember is that if I create a point here in space, or excuse me, in Python space, it won't render it out unless I use something like add point. But it doesn't mean I can't use it as a value, as a point within Python space. So I'm going to go in the demo lesson, I'm going to show those specific tools that you use to extract those point values from the GUID and why you would use them, when you would use them, and to clarify this issue a little bit further. This is a video that's entitled, What's the Point? Demo. So if variables are the building block of Python code, points are the building blocks of geometry and of Rhinoscript code. There's pretty much everything we do in creating geometry will on some level involve points, so it's really important to understand what constitutes them and how we use them, how we give them to certain functions, how we output them, see them. All these things are really important to creating geometry using Rhinoscript and Python. So if I just create a point in the scene and select it and type in what in the command line, I'll get some information about that point. So that point is carrying with it an ID, and it's also carrying with it its coordinate values. So a point is essentially a location in XYZ space, and that's what's represented by these three values, X, Y, and Z. It's laying flat on the C-plane, so Z is a 0 value. And it's this fundamental difference, I would say, between the point being an object that exists in space, having an ID, and an object and a thing that is just values. So that difference between those two things can lead to some confusion when using points in code, because I don't always need a point as an ID. I don't need it as an object that exists. For most things, I just need it as a series of values. And also, when it exists as a series of values in code, I don't necessarily see it within Rhino space. I have to, let's say, render it out in order to see it using those values. So it's this difference that I'm going to talk about a little bit, and how we deal with it with some of the fundamental tools that we use in the code. So if we have a line of code that's importing that point as an object and then printing out what that variable is holding, when I select that point, we'll see that it understands that point as an ID. Now I can use a tool called point coordinates. So I can use this function, and actually if we just copy this line, and here's a handy little shortcut I can show you. If you just put your cursor on the end of a line and you hit Control C and then return and then Control V for paste, it'll paste that entire line. So I don't have to select that entire line in order to cut and paste it. So I'm going to put that line up here. I'm just going to change this to point coordinate, and we're going to take point ID, point GUID, and we're going to run this function called point coordinates on that input ID, and then we're going to print out what that variable is holding. Okay, so we'll first print out the ID, and then we're going to extrapolate from that ID using the function point coordinates to find out what the coordinates are. So I can extrapolate from that ID my point coordinates using this function point coordinates. So we'll often have to do that if you get an error that some function is looking for point values and you're giving it an ID and it's breaking, it's not working. You'll sometimes have to translate or extrapolate from that ID the coordinates. I'm going to comment that out. Let's look at, so let's input 2 points. Before we do that, let's also look, there's another method I can use here to input a point. So I don't have to use getObject when I'm inputting a point. I could use a function called getPoint. If I use a function called getPoint, it simply sees that point as a series of values, so it doesn't carry the ID with it. So that's another option for inputting points. Now let's go back up to the top. I'll comment these 2 lines out. And I'm going to change these 2 lines. We'll input 2 points. So I'll uncomment those. And let's just change this variable. So I'm inputting those 2 points, and let's use those 2 points to create a line. So I need a second point. So run this, select a point, select another point, and it creates a line between those 2 points. And it didn't have this function, addLine, does not have a problem with points when they're ID values. If I look at that function closely, which we did in the last lesson, the last video, we went in here and searched out addLine. Okay, under parameters it tells me that it can both accept a point as values or an ID. So if we see this within a function, within the help menu of a function, we'll understand that it'll accept either of those. We can also do an add line. We can treat a point within the code as we don't need to deal with it as an ID. So if I run this, so this is creating a point or point value at 0 to 0, so 2 in the y value, so it should be on the y-axis. So I'll run that. Still selecting those 2 points, but I'll notice it's not creating a point there. So this point exists within the code just as a series of values. So another example of that is if I do another add line, sort of using those values directly hard-coded into this function, this should create a new line within the scene between these 2 points. And so you notice again that I'm seeing those points for this first line because they existed within the scene. And I input those 2 points and use those to construct this line between those 2 points. So I still see those 2 points because they existed within the scene. With this line, I hard-coded the start and the end point of that line. I don't see those start and end points as points that are rendered in the scene, but they still work within the code as points. Now, in working in code, you'll often want to see a point rendered out within the scene because I need to see it in space for a number of different reasons to see what sort of geometry that I'm creating with those points. If I want to do that, if I want to render a point value out in the scene, and essentially making it an ID, which I could also demonstrate, I need to use a function called add point. And so I'm just going to turn these off so we don't have to go through these. So I'm going to comment those lines out. Okay, so we're just establishing the point value here. We're going to render that value out using the function add point. And actually, let me delete these lines first. So it did create that point there. Let's do it one more time. So run it again. And now it's render that point sort of out in the scene. I can also use that point value. Instead of hard coding those values into my function, I could also use this variable which is holding those values within that function. So it's creating that line and it's also rendering that point out. We're going to, at some point, talk about another function called point add, which actually adds 2 point values together. It's significant too when we look at vectors, which are essentially points in space, special points in space with magnitude. So don't confuse these two. Add point is when we're rendering something out. Point add is when we're adding 2 points together, and if you look these up within the dictionary, you'll understand the difference between those two. So let's comment these out, and we'll look at one more section of code here, which I'll uncomment. And so here's a situation in which you might need to extrapolate from the point as an ID into a value. So we're going to look at some of these functions in the next lesson. Move object, copy object. There are a number of different functions which use something called a translation, which is a simple equation essentially calculated between 2 points, an endpoint and a start point. So if I just use these two as input points, and let's say we have a rectangle around one of them, and I want to move that rectangle over the distance between these 2 points using this first point as my start point and this point as my end point. So those are the 3 things I'm going to input. I get my curve, I get my start point, and I get my end point. And then I'm going to calculate a translation, and then I feed the curve ID into that function move object, and I feed the translation value between my endpoint and my start point. So I run that, select curve to move, it's asking within the command line. I select the rectangle, select start point, select that point, I select endpoint, that point. So now I'm getting an error, and it's saying the message is unsupported operand types for GUID and GUID. So I am giving in and showing me the traceback is line 28. So that's where my translation calculation is. So what this is telling me is that I'm giving it the incorrect type of data to perform that equation. And so this is a very common situation that we'll face in the code, particularly in the next series of lessons. And so I could do one of 2 things. I could either use my get point, which is going to input my points as just values, or I could extrapolate from these what my start point and end point values are using my point coordinates function. So let's do the second. So I'll copy this line. And we'll paste it in here before a translation function because I have to do that. We'll need to do it twice, one time for each point. And then I just need to change my variables here. So what I'm going to do is find the point coordinates for start point, and then I'm going to overwrite that variable start point with those point coordinates. And I'll do the same thing for endpoint. And then what we also might want to do is print out, we could say print start point, end point. Remember, I don't need to use parentheses for print in this version of Python. And then we could print those out. Let's copy that whole line. Just print those out after I do this and overwrite them. Okay, and then we'll do the translation with those, and then my move object. So let's run this again. So I select the rectangle, select the start point, select the end point, and it works. So it's moved that rectangle between those 2 points. It's printed out the IDs in that first line here, and then it's printed out the 2 values, which are now overwritten. If I wanted to save these separately, if I wanted to keep those IDs for some reason in those variables, then I would have given these different names and then changed it in the code down here to those different names. Again, there's nothing within the name of these. The name translation has nothing to do with its functionality, right? This could be, I don't know. I just have to write it the same exact way again, although that's going to tell me little about what it's doing. You could also play around with this and see what happens. What if I select this is my start point and this is my end point? Then my rectangle is going to move the other way. We're going to look at transformations, get into them a lot deeper in the next section of the lesson, but it's really important to understand these fundamentals about points and extrapolating values and the relationship between point as an ID and point as a value to understand what we're going to be doing in those lessons and ultimately the first assignment. This is a video titled Finding Points from Lines. What I've done is set up a code which takes a number of data inputs, and I want to just go through this first before I talk about how we can find points from input curves. I just want to point out a few things. This is my scene in Rhino space. I have a couple closed shapes, 1 degree curve, 3 degree closed curve, 3 degree curve. I have a straight segment line and 2 points. If we go back to the code, I can point out a couple things. So in these first 3, in my message, I'm asking for a curve, a line, and then a shape, and saving these in different variables. But if you notice, over at the filter, they're all called curve. So even though I'm calling these things different things and they are different types of objects in Rhino space, when I bring them into Python, it sees them all as a curve, and curves are different degrees. Although we can understand that a curve may be something that has more than 2 points. So a line, just in terms of terminology, a line is a straight line between 2 points, and a curve could be a polyline, so it could be a series of straight segments, but it tends to be more than one straight segment. And then there are some tools we're going to find that do make distinctions between whether or not a shape is closed or open. So for example, if I wanted to find the area or the area centroid of an area of a shape, it would have to be closed for me to do that. So I just wanted to make that terminology clearer, because we do tend to call these things different things, but they are input exactly the same way, so they use the same exact filter. And then we already looked at 2 different ways to input a point, one using the get object, which brings it in as an ID, and another one that brings it in as a coordinate. I may need to convert that ID into point coordinates, so I can do that using the point coordinates function. And then here I'm just printing out the data. This first part, this string part of the printout, has nothing to do with the functionality of what's printing it out. I'm just labeling everything, so it makes it clear. So if we run this, select curve, select a line, select one of the shapes, select one point, and then the next point, and then it's printing out all of that data. And that's, so we've sort of gone over inputs a bit in these first couple lessons, and this should all start to make some sense. So now the question is, what can we do with some of this input data? So I've set up another code here, and one of the first things that we can do is we can find from any of the curve input data, we can find points from that. So initially this isn't the only kind of points that we can find from curves, but this is a good place to start. We can find a start point and an end point out of a curve. When I draw a curve in Rhino, if I click on it and I type in dir up in the command line and hit enter, it's going to show me the direction of the curve. So every curve has a direction to it, whether or not it's an open curve or a closed curve. It's the direction that I drew it in. It can be flipped. We can look up in the command line, and it does give me an option when I type in dir that I could flip the direction of that curve. Why that's significant is that my direction also means my curve has a starting point and an end point. So when I'm finding in the code, using the function called curve start point, I'm finding the start point of that curve. And let me turn off the bottom part of this code for a second so I don't run that. So Shift Control C, comment that out. Okay, so I'm just doing this for the first for one curve ID. I'm going to find the curve start point, the midpoint, and the end point of that curve, and then I'm going to save it in these variables, and then I'm going to print that data out. So we can turn these off also, because I'm not going to do those yet. Okay, I'll run this. So select a curve, that one. It's showing me what those variables are holding. So that each one of those variables is holding a point coordinate value, so an XYZ value. And it's saving that in those variables. I don't see those points, right? Remember from the point lesson that there's a difference between sort of rendering a point out and that point being a set of values within the code. Now, if I wanted to see them, I would have to render them out. So let's do that. So Shift Control U for uncommenting that section. Actually, let's do this first. I'll explain that. Explain that after. Okay, so I'm taking those coordinate values and then I'm using the function addPoint to render those points out in Rhinospace. So we'll see what that does. Okay, now I have 3 points. I have a start point, midpoint, and an end point. Now the thing to remember also is that these are, even though they were derived from this curve, they are separate entities. Right? So those are separate objects. They're not tied in any way to the curve. That's going to work for this curve ID. I could do it for, we could replace, turn this off, turn our line back on, replace that in here. Oh, I have a space. So run it with the line ID. Of course, that doesn't really matter, right? Because I could select, even though I'm saying line, I could still select that curve. It's going to run the same, right? We can even do that. So I could select that curve. Just because it says line, it's still inputting a curve and doing that. Right? So I don't really need these different input names. I just write it out like that, right? To make it, to let myself know, or if somebody else is using the code, to make it understandable what that's holding. But yeah, we could run it on this straight line. It's going to create 3 points. And then I can even run it on a closed shape. And let's just run that. So select any one of these. Of course, it's I'm only seeing 2 points because if my shape is closed, my start point and my end point reside in the same position. But I do create 2 points. I can see from the selection menu there's 2 points right on top of each other there. This is my midpoint, so that's 1 point. And then the last thing I do down at the bottom here, point I'm trying to make, is I could set that rendering of that point, add point, that's returning. Not only does it create a point in the scene, but it also returns an ID value in the code. So if I wanted to do something with that, or if I later wanted to delete that, in the scene, I could use a function delete object and sort of erase that geometry in the scene. But this is showing, line 23 is showing, we'll print out that ID of that point. So I'll run this one more time. So here it's printing out the ID of the endpoint, and then it created 2 points there, the start and the end of that closed shape, and then the midpoint there. Okay, in the next video we're going to start to talk about transformations, how we can input our curves and finding points from them, but also and using input points to do things like rotation, scaling, moving, copying, and this will lead to our first assignment. This video is entitled Transformation Rotation, and it's the first in a series of videos that I'm going to do that will look at basic transformations leading up to our first assignment. So starting out with rotation, I think one of the probably easier ones to understand. And I'm just going to use as an input just a simple line. And from that line, we'll find are different points, start point or midpoint, end point, and I'm going to start with rotating around the midpoint. Now, rotate object is a function that has a number of arguments associated with it, and some we haven't seen. It's probably the most that we've seen. It takes 5 arguments, and there are a couple of things I need to go over with those. You know, what sort of information is it asking for? What format does it have to be in? And what is it giving me back? So we can look up rotate object in our online help and see what those arguments are asking for under the parameters. So the first one's pretty clear. It's the object ID, so the ID of the object that I want to rotate. And then it needs a point to rotate around. And that could be a point that's derived from that object, or it could be a point that I select in the scene, or a point from another object. And then it needs a rotation angle in degrees, which is a number. Doesn't have to be an integer. Could be a float. And that is either in a positive or a negative, depending on which way I want to rotate. And then it's asking for an axis. And this is optional. And that axis is defined by a plane, and it's telling me that if that's omitted, then it's just going to use the z-axis of the active construction plane as its rotational axis, and we'll look and see what that does. We don't know anything about planes yet, so we really can't put anything in for that. We'll talk about planes in a much later lesson. So we're going to look at how because a problem here is then I have an argument that follows that I do want to do something with. So copy. So what if I want to produce a copy of the line that I'm rotating? So I just don't want to rotate it. I want it to copy. And I have a BOOL, which is a Boolean option, which means I'm inputting into the argument either a true or a false, depending on whether or not I want to copy the object or not. And that's also optional. If I left that out, we could see it. I could leave these last two out. We could try that first and see what it does. It'll probably just rotate the object. It probably won't copy it, but we'll see. We'll see what that does. So let's go back to our coding window and see what we have set up. So I'm going to take these last two arguments. The first thing I'm going to do is I'm just going to leave them out because they're both optional. And we have our curve ID. We're going to use the midpoint, and we're going to rotate it positive 25 degrees. So let's run it. So select the curve, and it rotates it around the midpoint 25 degrees in the positive direction, which is actually a counterclockwise direction. So clockwise is negative and counterclockwise is positive. I know it seems like it should be the other way around, but that's just the way it does it. It is not copying the object by default. Now I can undo that. And remember, it's using that midpoint, but I'm not rendering it out. So I don't see that midpoint, but it is rotating around it because this is accepting a value. What this is returning is the coordinates of that point, and that's what that accepts. Okay, so the question is, if I want to skip, if I do want to produce a copy, so I want that last argument to be true. Okay, I want to say yes, produce a copy of that line, but I need to skip this one here. So in order to do that, in order to skip an argument, I need to write, and if that argument's optional, I need to write none. So I need to write the data type none, which essentially means nothing, don't input anything, but input none as a data type. So we can run that, and we'll see what that does. Okay, so now it's producing a copy of that line, and I could run that over and over again, selecting each new copy, so I could produce a sort of rotational geometry like that. If I wanted to produce copies in the other direction, I would change that to negative. Okay, so let's take this original line and we can move it, and if I hold the Alt key down, it'll make a copy of that. We could rotate that, let's say around another, if I wanted to rotate it around another point, like the start point. I could replace the midpoint here with start point, and let's say rotate it, in a different degree, 15 degrees, and I'm still producing a copy of that. Okay, so again, the axis that this is rotating around is whatever the axis of my C-plane is. The z-axis of my C-plane, I should say. So if we, arc rotate in space to take a look at our plane, it essentially means that, that point that this line is rotating around is like our world coordinate center, with the z going straight up out of this, 90 to the other two axes, and that's the axis that it's rotating around. We can do another version of this. Hold the Alt key down, produce another copy, and rather than using a point that we derive from the line, we could, input a point. So if I go back to the code, turn this line 6 on to input a point, so that would be point ID. I guess the question is that going to work if it's not coordinates? If it's an ID, because remember what I'm bringing in here is an ID. If I look back at my tool, my point, well, it's saying point as the center, so it's probably not going to work, but we'll see. Nope, that works all right. So this tool does accept an ID. I don't have to convert it to coordinates. So I can keep rotating that around that input point. Okay, so it's using that, right, as if I imagine a z-axis coming up straight out of that point, that's the axis this is rotating around. Now, if I change the position of my C-plane, so if we copied these two things over, we moved our point over a little bit, and let's say we tilted our C-plane up into a front view like that. And if we ran the same code again, now my line is rotating relative to that C-plane. So that C-plane, the position of that C-plane that we put it in, is going to have an effect over the axes of rotation. So that really, its position really sets the rotational axes. So that's rotation. Next we're going to look at scale. This video is titled Transformation Scale. So scale is our next transformation, and I'm going to use two different types of closed shapes to show scale. It doesn't necessarily have to be closed. You can scale any sort of shape or object in the scene. We'll take a look at the function first in the help to see what it's asking for. So search scale object, and so it has 4 arguments, 3 of them required and 1 of them optional, as we saw with the rotation, that the producing a copy is optional, so it'll work the same way. So it takes an object ID. It needs an origin point for the origin of the scale. And then it's going to need 3 numbers that are either put between brackets or parentheses. And they identify the X, Y, and Z axes scale factors that I can apply to something. If, for example, if I put in 1, 1, 1, then that's going to be 100%, and it's not going to scale the object at all. It's going to be 1 to 1. If I put in 0.5, it's going to produce an object that's 50% smaller than the input object, and 1.5 would be 150% larger. And we'll also see that they don't have to be the same 3 numbers. So I can do non-uniform scales with this function. So here I'm inputting curve ID. I'm inputting a point that it's going to scale around, and I've put in 3 numbers in a set of parentheses that are 0.5, so I'm scaling it down by 50%. And then I've put in true because I want to produce a copy of the object. So I need a point. So if we put one sort of roughly in the middle, select the curve, select the point, and it's going to produce an object that's 50% smaller. I'll run that again. Okay. So if I move the point outside of that object, let's say over here, and we'll scale this one, that shape. It's going to scale towards that point because it's using that point as its origin. Now I could maybe use a point that's actually generated from the shape itself. So instead of using this input point, let's use a centroid point. And I'm just going to turn this off for a second, so we'll just take a look at this function called curve area centroid because it does a couple of special things that we haven't seen yet. And actually, let me take this off the end. And we're just going to start by printing it out. But let's take a look at it in the help. So curve area centroid. So that just takes a curve ID, and it's also a very specific type of curve. It's got to be a planar curve, so it has to sit flat on a plane, which these do. What does it return? Well, it returns something called a tuple, a point and a vector. So I don't know what a tuple yet is, or I know what a tuple is, but you guys don't know what a tuple is yet, or some of you, most of you probably don't know what it is. We're going to cover that in lesson 2. We'll get into tuples and lists, but it's essentially returning two things, and it tells me right down here in the description what those two things are: a 3D centroid point and then something called a 3D vector. We don't know what a vector is yet, but that is listed, the 3D point is listed under a number 0, and the 3D vector is listed under number 1. These are index numbers that identify where that data is held in the tuple. So I just want to ask for one of these. So I just want to ask for the 3D point. Now if we just run the code, and so I'm just selecting the curve, and then it's generating the curve area centroid, and then it's outputting it in a variable called centroid, and then I'm just printing that data out. So let's just take a look at that. Okay, and so it's showing me this thing called a tuple, which is holding two items. So it's holding a 3D point, and then it's holding a 3D vector. So just what it talked about in the help. And I just want the 3D point. I want this first one. So how I tell it to just take the first one is at the end of the function, where I call the function, after the last parentheses, I'm going to write in brackets that 0. Okay, if I go back to my help, I'm asking just for that element, just for the 3D point. So if I write that after the function, it's just going to return that 0 element to the centroid. So just this first one. Now if we run it again, I can see it's just returning it's just returning the 3D point, which is an XYZ values. That's what it's printing out. So if we wanted to plot that out, I could use this add point, could run it again, select that curve, and now it's plotted out that point. And so now we can use the centroid instead of the input point to scale the shape around. So as I said, we could also, it doesn't have to be a uniform scale. So if we kept our x-axis at 1, then it should create a sort of squashed n-gon here. So if I change that from 0.5 to 1, and it's sort of holding its dimension in the x. or I could, increase, let's say if we went to, 2 in the Y and did this for the other shape. So it holds my X, but then it really starts to stretch it out within the Y. So that's the scale object function and how you would use it in a sequence of inputting geometry. And we'll look at move and copy next. The title of this video is Transformation Copy Move. So in this video, I'm going to be talking about the copy move functions, and I talk about them together because you'll see in their operation and what they ask for, there's a strong relationship between them, and we really set the data up in the same exact way. If I go to, again, to my help, and we'll just type in one, we'll start with move. So move object. It only needs two things, two arguments, an ID and something called a translation or vector. I talked about this a little bit in the lesson on points, but I'll go over everything again here. So that translation is an equation. Translation simply holding as a variable name that's holding the result of an equation that's produced between 2 point values. So the end of my movement or my copy and the start. So using, in this case, taking 2 input points, but the points could be hard-coded, they could be generated within the code or from some other object. That translation has to be calculated, and then the move function is taking that ID and that translation. Copy is essentially the same, asking for the same exact things. It's just we'll copy the object instead of just simply moving it. So it's pretty much identical in its operation. So let's take a look at this with move. One of the things I need to point out is because this equation, this expression right here, translation, is really just a simple mathematical equation subtraction. So these need to be values. It's not going to work with an ID. So from my input points, I save those IDs as in these variables, and then I find their coordinates, and then I overwrite those variables because I don't really need the ID of the points. And then I use those coordinates to calculate my translation. So if we start with this first shape, and let's say we wanted to move it over a distance and direction represented by these 2 points. So I run the code, select the curve, that's the first thing I do, and then select the from point. So what point do I want to move from? I'll click the one down at the bottom first, and then select the 2 point. And it moves that n-gon over that distance. So if I wanted to really sort of explain that spatially, what we could do is just mark let's say the start position of that figure with a point. And if we ran our code again, selecting the curve, the from point and the 2 point, and then draw a line from the from point to the to point, then move that line back to that starting point, we'll see that those points have a correlation to the movement of that object in space. So these points could be anywhere in space. They're just going to dictate the direction and the distance that that object is moved. More than likely, you're probably going to use copy instead of move on this in this first assignment, because you're probably going to want to produce copies of objects. So we'll get right to that because it's pretty much works the same way. Okay, copy object. Select the shape, the from point and the to point, and it's just producing a copy. Now I could also use, as I did with scale, we could use the centroid of the object as our from point. So if I turn that section of the code back on, find our centroid, I don't need to render that out, and I actually don't need to print it out because I know what it is. I know that it works from the last lesson. So we're just going to take centroid and we're going to replace the to point, or the from point, sorry, in our equation. And then I can also turn off, I don't need to collect my from point, and I don't need to calculate its coordinates, so I'll turn that off because that would throw an error. Okay, now if I run this, I can select that shape and then just select a to point. I could copy it to that. And we can continue to run it, doing that. Now, this brings me to another point. There's a lot of ways that we can generate points, and that we're going to find out eventually within code, but we can also do, with this first assignment, we can do a couple things manually to create a geometry of points that we're copying things to. So if I gave myself a curve over here, and we typed in the command line, divide. If you worked a lot with Rhino, there's a divide curve which produces a set of points on that curve. And I could change that number, but gives me a sort of, not only a set of points, but also an order to them because they're following the curve. So if I ran the code selecting that shape, and each point on that curve one at a time, I could start to create a kind of pattern through this copying based on that order that I'm giving it. And so we're going to, in the last video in this section, we're going to bring sort of all these transformations together, and we're going to talk a little bit about what you might be doing in the first assignment with these inputs and points and things that you can do in Rhino, but that you can also input in and do in code. But hopefully these three lessons, three demonstrations start to show you some of the possibilities of what you can do with just inputting simple geometries and then using these transformations to manipulate them to produce geometric patterns. This video is titled Transformation, Putting It All Together. In this video, I'm going to show you how we can put multiple transformations together to manipulate the geometry of shape. And this is really what you're going to be doing in the first assignment, something similar. Now I'm kind of simplifying it a little bit by, I'm just going to use a single shape. You can of course use multiple shapes in the first assignment, as many as you want. One of the things I'm looking for though in that assignment is not just a manipulation of this shape, but doing that in a really sort of calculated way where you're able to produce these transformational patterns of the shape. So it isn't just their change in one stage, but how do you do it? How do you make a progressive manipulation or a progressive transformation to a shape? So I'm going to demonstrate a little bit of that, and then on also how to combine multiple transformation types, so rotate, moving, scaling, all in one code using all of the things that I've showed so far in this lesson. So this code should look pretty familiar to you. I'm inputting some data, selecting an object. I'm selecting a point to either move or scale to. I'm finding the coordinates of that point. I'm finding the centroid of the shape that I'm inputting, calculating a translation, and then the first thing I'm going to show is a rotate and then a scale. Just something to explain in here. I do the rotation first because I want to rotate around the centroid. If I scaled or moved the shape, since I'm finding the centroid with the input shape, if I scaled or moved the shape, I wouldn't be rotating around. I mean, I'd still be rotating around the centroid, but the centroid would be here and the shape might be someplace else. So it's not going to rotate around its own center. So I want to rotate around its own center first. So that's why I do rotate object first. And I also do something else here. So my copy is set to true, so I'm producing a copy of it. And I want to save that copy in a variable called new curve. Since I'm going to want to sort of show this progressive differentiation of this shape, I want to produce copies of it. And so I can do that at different steps, but I decided to do it in the first step, which means that the object that I'm going to scale is not the original object that I input, the one held in curve ID, but it's this new one that I've rotated. It's going to scale it towards that input point. So I have a point out here, and so it's really going to, so I don't need to move this object because it's going to scale it towards that point, and it is going to move it because of that scale transformation. I'm scaling it by 80%. And again, that's something you can adjust, and you can do non-uniform. That's something you can really play around with. And I'm not producing a copy, so I say false here. Now I could just have left that out, but in order to demonstrate that I'm not copying something, I'm not producing a copy, I'm writing false in there. Okay, so let's run this. So I select the curve, and I select the 2 point. And so it's rotated, first rotated that, I think I did it 20 degrees in the counterclockwise direction, and then scaled it 80% towards that point. So if I ran this again, selecting that copied curve, the point, I could do this over and over again, selecting each new curve. And I would start to get this kind of transformational graphic pattern of this curve kind of rotating and scaling through space. So the production of this kind of pattern with a shape or different shapes is really the crux of the first assignment. How do you create, using multiple transformations, how do you create 2D patterns with shapes? So that's one methodology. Another methodology could be that you have maybe some driving shape. Maybe it's a circle, and on that circle you divide it and you find a series of points along that circle, and I could use those points as points to copy my shape to and rotate it around. So let's go back to our code. We'll make some adjustments. So this, I'm not going to scale it this time, so I'm going to turn that off, but I am going to move it. So we'll still rotate it around its centroid, still producing a copy, and then we're going to move that copy to the point that I select, and I'm going to, instead of selecting this point over here, I'm going to select points on this circle. So I'm going to produce copies of that shape as it rotates around. And after I do the first one, I'm then going to select that shape that's already on the circle because I want to do progressive rotations. If I kept selecting the original, it would continue to just do the same rotation. So let's run this. Select that curve and select a point, and it's copied it. So if I keep running this, selecting that new curve, okay, so you get the idea. So I'm able to produce these patterns from an aggregation of shapes which have a kind of base structuring element that controls their organization in space. So that's really an important part of this project, is that you have some way of sort of controlling that pattern of transformation. One other methodology might be, you could create a curve. You could also divide that. And let's go back to our code and let's see, what do we want to do? So we'll move it. Let's also, we'll scale it. We'll see what that does. So again, when I do the move object, something we probably haven't seen here. So I rotate the object, this first object, and then I save it, that copy of it, which I'm copying here, I save in this new variable. That's the one I'm moving, right? Because it's in here as one of the assignments. And then I'm overwriting that again as I move it. And then because I'm moving it to a new position. And then I'm scaling that here. So let's run that. Select a curve, select a point. Let's continue to do that with these. So in this case, I'm getting a move, a rotate, a move, and then a scale. That's also following this trajectory in space. Okay, so a couple different methods. Obviously, there are others. You could have, multiple shapes that are driving this. You could do non-uniform scales. You don't have to have, this doesn't have to be a closed shape. You could work with open lines. It could be curvilinear shapes. Anything that you can come up with is fine to use. It has to be two-dimensional, and it has to produce this kind of pattern transformation. And that's it. So have fun. The other thing I want to point out too is that this sort of selecting and clicking of the points seems like there might be a better way to do this with code. It seems tedious, and you wouldn't be wrong in saying that, but what this is leading up to, that we will be able to automate these processes when we look at things like we're going to introduce lists and iteration. So we'll be able to do things like collect many points in an organized manner, or produce that list of points from a curve, and then loop through those and do these transformations on that. So we haven't gotten to those tools yet, but this is leading up to that. And so all these processes will be able to be more automated, but this is the first steps to that. So a really unique part of this course is the gallery tool. So this is an environment in which you're going to be sharing your own work, whether it's still images or animations, or even the code that you're working on. And you're also going to be able to see work of other learners. And we think this is a really important part of this course, to have this kind of exchange of information, and also to be able to comment on each other's work and peer review each other's work. I think that's a really important part of learning, to be able to talk about somebody else's work in a constructive way. And I know it's been a really important part of my learning throughout my career, to be able to teach and comment on people's work. So I wanted to use this video to talk a little bit about some of the guidelines for doing that, and maybe demonstrate a little bit how we can talk about work. What we've done with each assignment is not only giving you the assignment, but we've also given you a commenting rubric that's specific to each assignment, although it does share a common three-part scheme, three different ways in which you might start to think about the work. So there's design, presentation, and code. Design has to do with how you're going about designing the elements that you're producing within the course. How much does it vary from some of the things that I'm showing in the tutorials? Is somebody really starting to do something that you can't really figure out sort of how they're doing it, but it sort of piques your interest, and they're doing something unique. So how are they pushing the limits of the design aspect of it? Presentation has to do with How are they showing that? Are they using the presentation to show a variety of different types of geometries that can be produced with the code that they've made? And there is a kind of crossover, I would say, between design and presentation. Oftentimes you can't completely separate representation from the thing you're representing, that those things can often be very closely tied to each other. The last part is code, and code's really about how the code is presented, how it's organized. It's not always about the originality in the code, but it's about its legibility related to some of the things that I'm going over in the course, and also in terms of how it's commented, how clear is it to understand what somebody is doing with the code. Now, commenting on work and also receiving comments on work is going to be an important aspect of the course, and it's important not to, it's not about commenting on the person themselves, but it's about commenting on their work. So it's important to be very inclusive and open and helpful and constructive within your criticism. It's also important not to take the criticism personally. What I tell my residential students is don't put yourself between the commenter and your work. That means don't be in a position of defending your work. You want to be open to comments. You want to be frank about what you're doing, and you want to have a discussion about it. So don't be defensive. Now, there's tools for commenting. One of my favorites is the like-wish method. So I like to start by talking about what I liked about a project and starting it with like. And not just saying that I like it, but why do I like it? What are the certain aspects of it that I like? If I don't like something about a project, I don't use terms like hate or that I really don't like that, but instead I try to use the term wish, that I wish they had explored this a little bit further. I wish they had maybe shown more variation in this. So it's a way of using language to be more constructive and more engaging with the other learners. And that's a really important part of this. You don't want to, it's not about attacking someone for something, but it's about helping them and helping yourself. Now, what I'd like to do is show a couple of projects and talk a little bit about what I think is the qualities that I like within the projects, and maybe what they could have worked on a little bit more. These are projects that might be around the level of, that you might get to around the 4th week of this course. They're working with a 3D point matrix to create a variable geometry. So this first one, I would say, is about in the upper middle level of work. I think it's these 4 illustrations are really demonstrating very well how they're producing variation within the system, that it goes from a sort of more ordered, rigorous system that's adhering to the grid, and that slowly sort of breaks down. I think the way they chose the representation that they chose, this kind of almost drawing-like, I think works very well with these angular forms. I don't think the project diverges to a really great degree in terms of its the design coding from what I showed in the tutorials. So that those aspects might have been pushed further, but it's not a it's a fairly good project. This project is, I would say, not as strong as that last project. The things that I like about it, I like their use of color. I like the levels of transparency in the project. I don't think the 3 images, I wish they had shown maybe some different angles of the project. It's difficult to understand what it is that they're varying within the geometry. All these 3 images all sort of share the same angle, so I wish they might have shown it from different perspectives, might have given different sort of views and a different understanding of the project. This one is not as strong as those other 2, so I would say this is on the sort of weaker side of the projects. Although I think it accomplishes a number of things in terms of addressing the assignment. I think it does show some variety in the types of geometry produced, but probably not enough. I don't think it goes far enough that I wish it had gone much, much further. Things that I like about it are these sort of umbrella-like forms which seem to float in space. I don't think the 6 illustrations are showing enough variety or change in the geometry. I think the quality of the presentation is a bit sort of standard. It's a standard rendering in Rhino, and so those aspects of it haven't really been pushed that much, and they could be pushed a bit further. This project, I would say, is on a higher level than the ones we've seen so far. It does show a good variety in form. This is only one illustration of a number of illustrations that the students submitted for this project. You wouldn't recognize it at this point, but they're doing something very sophisticated with the code in order to get the matrix to generate this specific types of form. So at a design level, it's a bit more advanced. I think they could have done more with the presentation and the different sort of angles in which they and ways in which they showed the work, but it is a strong project for these other reasons. This last project is not, I would say it's not as strong as that last project in terms of its the coding that was involved in producing it. The coding wasn't as complex, but I think in this case, the level of presentation trumps the complexity within the coding. I think it's an extremely sort of evocative project. I really like the way that they're using both solid rendering and line work, that there's this kind of delicacy within the project, but then there's also a weight to it. I think the absence of color within the project, I actually think works better for it, gives it this kind of austere quality. and they presented a number of illustrations of it that showed it in different varieties that were produced from the code. I think too, also, what I really like about this project is it shows the complexity possible with doing something through code. If you could imagine if you had to manually model this and produce these variations within these illustrations, it would probably take you weeks and weeks to do that, to do a single illustration. And so it really represents the power available within coding to produce that kind of complexity and variation. And so I think it's, for this level, I think it's a really extraordinarily illustrated project. So the last issue is the code. And so, as I said, you're not going to be inventing completely from scratch new code. What you're really doing is working with the code that I'm giving you, maybe editing a bit, adding certain parts to it. So commenting about it isn't about commenting about a completely invented new code, but it's more about its organization, how is it presented, and its legibility. And that has to do with a couple things. One of them is the use of variable names. So can you clearly understand sort of the mnemonic structure of the variables, where they're important, what they're holding? So that's one aspect of it. So looking at this code, there's definitely, it's very clearly organized. They have this area where they're declaring all their empty lists, and everything is really well commented, which is all these green text parts. They tell me exactly what these individual things are. You have comments at the beginning of sections of the code here, which really explicate, what the code is doing. So if I've never seen this code before, it's fairly easy for me to go through it and understand what it's doing and how it's working, because of the clarity of the variables and also the clarity of the comments. Now, this is probably, at this point, this is a lot more complex code than what you're used to seeing. And it has a number of different elements in it, like functions and iteration and a whole bunch of things that maybe we haven't gone through yet. But that's okay. I mean, you could sort of look at it and probably see that how it's clearly organized. The other aspect of the code is that in some assignments, I will be asking you to do certain things in the code. So in some of them, I'll say specifically, you should use conditionals in this, or you should use iteration in this, or you should use a dictionary structure in this. So the other issue around the code is, are you using those things which are required within the assignment? And so if we look at a code that's another code that it works just fine. And it's actually doing some interesting things in terms of its design. I would say where I wish that it did things better was in its commenting, and also perhaps in the way that some of the variables are named. They're not really telling me too much about what they're doing. I don't know, this is a conditional part of the code. I don't exactly know what that's doing because it's not commented out. I don't know, this is definitely creating geometry here, but I don't know exactly what for. And so I would have to spend some time picking through the code to figure out what it's doing. And that would have been helped by more comments within the code to make those things legible. So that's what I'm talking about when I'm talking about code. So I hope this video has helped you understand a little bit about the critiquing process and a little bit about what we're looking for in some of the assignments.